Okay, so hi everyone. In this video, we are going to discuss about the pigeonhole principle. In the last lecture, we have discussed the basics of counting, primarily the sum rule, the product rule, the division rule, and the subtraction rule. And if you remember, the subtraction rule is similar to the mutual inclusion-exclusion principle. So today we are going to focus on the pigeonhole principle as well as the generalized pigeonhole principle. So first, let us discuss what the pigeonhole principle is. So assuming that you have k pigeonholes and n pigeons, that will be placed in them. So if the number of pigeons is greater than the number of pigeonholes, then at least one pigeonhole contains at least two pigeons. So what does it mean actually? So assuming that you have 9 pigeons, and that will be the n that we have mentioned earlier. And we also have the 8 na pigeonholes. So we are going to place these pigeons into the pigeonholes. So the counting na problem would be that how many pigeons would be in each of these pigeonholes. So with the pigeonhole principle, if we have more pigeons than the pigeonholes, then at least one of the 8 na pigeonholes must have at least 2 pigeons in it. So we can visualize it like this. So let's say you have 9 pigeons here, and then we only have 8 na pigeon holes to roost. So the pigeonhole principle says that at least one of 8 na pigeonholes must have at least 2 pigeons in it. So we can map this first na pigeon into the first pigeonhole, the second pigeon into this second pigeonhole. But as we have mentioned, we have more pigeons than the pigeonholes. So where are we going to put this extra na pigeon? So this extra na pigeon can be put in this pigeonhole, or maybe this pigeonhole or pigeonhole. So by the pigeonhole principle, again, at least one of these 8 will have at least 2 pigeons in it. But this is not limited to this restriction. Okay, so we can also have, let's say, this pigeonhole will have these 2 pigeons in it, and this another pigeonhole will have this 2 pigeons roosting on it, and this other pigeon will be empty. Still, with this new na placement, we still comply to the principle that at least one of this must have at least 2 na pigeons. So we have this pigeonhole with at least 2. Then we have this another pigeonhole with at least 2. Okay. Now, this kind of placement is also this also complies to this principle. Okay. So we mentioned that at least one of 8 pigeonholes must have at least 2 pigeons. So this is still correct, that this pigeonhole could have 3 na pigeons. So 3 is at least 2, right? So, and while the others will have empty na pigeons. So this is also true. Let's say we have 4 pigeons that are roosting in only one pigeonhole, or maybe this is also correct. At least 2 na pigeons is roosting in this pigeonhole as well as this, and the others are empty. And this is also correct, assuming that all of the pigeons are placed in only one pigeonhole. Still, it complies to this principle that at least one of the 8 na pigeonholes, at least one only, so we need a minimum of 1 pigeonhole that have at least 2 pigeons in it. Okay, so in terms also of a set of objects and a set of bins, so assume you have a set of objects and a set of bins used to store objects. So the pigeonhole principle states that if there are more objects than bins, then there is at least one bin with more than one object. So for example, if you have 7 balls and 5 bins to store them, so we have 5 bins. So we are going to distribute these balls into the bins. Okay, so the pigeonhole principle states that there will be at least one bin with more than one object. So we could distribute this ball to this bin, another ball to this bin, each ball, the 5 balls will be, let's say, distributed to each of these bins. So we have 2 extra balls. So where are we going to put them? So we are going to be placing them in any of these bins. So by adding those extra balls, there will be at least one bin with more than one object. Okay, so how do we use the pigeonhole principle in problem solving? So we can interpret the pigeons as the numbers or the objects, and the pigeonholes are the properties that the numbers or the objects might possess. So let us have an example.